Good morning, everyone. Uh, Thank you for attending this session about secrets of SQL Dedicated Pool. My name is Dennis Torres, and a bit about me. I'm a data platform MVP with some Microsoft certifications. I live in Malta. I'm the Malta Data Platform User Group leader. And you can see on the right side my contacts. Feel free to get in touch. It will be a pleasure to connect. And if you have any questions about this session later, you can also send me by mail, by LinkedIn, Twitter, any way you would like. We will be talking about dedicated SQL pools. And the common idea on the market is that the Azure SQL Data Warehouse became the dedicated SQL pool. That's true. Before we had a product called Azure SQL Data Warehouse, and some people in the beginning became confused, thinking, "Oh, Azure SQL Data Warehouse became Synapse Analytics." No way. Synapse Analytics is way more than the old Azure SQL Data Warehouse. The Azure SQL Data Warehouse that we had before, they became the dedicated pool inside Synapse Analytics, one of the Synapse Analytics components. So in the workspace of Synapse Analytics, we have the on-demand pools, the SQL pool, the dedicated SQL pool, and the Spark pools. I think you saw more about this structure on the previous session, so we can move forward of this. The point is, there are many people that think that a SQL data house or a dedicated SQL pool is something like a SQL database. There are many people that see them as a SQL database, and this is absolutely wrong. Wrong. In fact, I believe the old name that these two had, Azure SQL Data Warehouse, was a terrible name. Was a terrible name to the market, because many companies in the market start thinking, "Oh, I need a data warehouse. If I need a data warehouse, what product will I use for a data warehouse?" Then the company finds the Azure SQL Data Warehouse inside Azure and think, "Oh, that's it. I need an Azure SQL Data Warehouse." And that's not true. Azure SQL Data Warehouse is not a regular SQL database. It's something else. That's what I will show on this session. What is the dedicated pool? Which was the old SQL Data Warehouse. The dedicated pool is a server using MPP architecture, massive parallel processing architecture. This means that we have a control node. This control node receives queries. Our queries are arriving on the control node. Then these queries are broken down in many compute nodes. Many compute nodes will be responsible to process our SQL queries. And the data is in a single store, which is accessible by these nodes. These nodes are capable to access this store. So this is the SQL dedicated pool. The fact that the SQL dedicated pool is not a single database is a massive parallel processing architecture. This explains why the Azure SQL Data Warehouse is more expensive than a regular SQL database. Why the dedicated SQL pool is more expensive than a regular SQL database? Because it's not a single database. It's a complete node compute pool, a complete set of compute pools managed by a control node that will process our queries. So this is intended for a huge amount of data. So you will not go directly to a dedicated pool only because you need a data warehouse. No. What's the size of your data warehouse? Is your data warehouse big? Is your data warehouse small? There are small data warehouses with small query requirements that would fit perfectly in a regular Azure SQL database, in a regular Azure SQL without the need of the SQL dedicated pool. The SQL dedicated pool is intended for a data warehouse, yes, but for a huge data warehouse. A data warehouse that requires a great response time over a huge amount of data. Then you will have the massive parallel processing architecture at your hands. So what lies behind the curtains? When we look to the SQL dedicated pool, we see one database. It appears, oh, we have a database here. That's one fact that makes most people mistake it by, oh, it's a SQL database. It's not a SQL database because we'll make a query thinking that it's a SQL database. But our query is in fact being broken down among many nodes. A single table, what we see as being a single table, is in fact broken down on many different nodes. And the MPP architecture on the dedicated SQL pool will retrieve these using all the compute power of these nodes. And, oh, it just works as magic. No. The planning for this structure is completely different than the regular planning on an Azure SQL database. How our data will be broken down on the distribution and how our data will be broken down on the compute nodes, we need to plan that. And if you make a mistake on the plan, our queries will have poor performance. That's bad. So we need to know the details about what lies behind the regular SQL dedicated pool, what lies behind what the let's say front end that you see as a SQL database, and make our planning on the tables based on that. For example, this is the performance level of a dedicated SQL pool. Mind that the performance level starts on DW100 and goes up to DW 15,000. 15,000. And what's the difference? The difference is the compute nodes, the number of compute nodes which is provided for each performance level of the dedicated SQL pool. Mind that below DW1000, everything is considered as, let's say, a test environment, not really a serious MPP environment. Why? Because you are creating a single compute node. From the W100 to the W500, you are creating a single compute node. So in comparison to what the SQL pool is intended to do, this is considered a testing environment. So things start to become serious after the W1000. After the W1000, things start to become serious, and then you start to have 2 compute nodes, 3 compute nodes, 4 compute nodes, until the W15,000 that gives you 30 compute nodes. All the examples that I execute today will be executed on a DW2000. I'll be using 4 compute nodes for the executions. As you see, it's almost the lowest level that we could have on a SQL dedicated pool. So we can go very high on an MPP architecture using the SQL dedicated pool. The third column that you are seeing is the distribution. Distributions per compute node. What's a distribution? A distribution is how our tables will be broken down. How our tables will be broken down along the MPP architecture. And there is a secret. We will always have 60 distributions. The number is fixed. You always have 60 distributions. What happens is that these 60 distributions will be broken down along the number of compute nodes that we have. So on the test environment, let's say that has only one compute node, all the 60 distributions are there on a single compute node. But in an environment that I have 4 compute nodes, then I have 15 distributions on each compute node. And this goes up until the level that I have 2 distributions for each compute node on the DW 15,000. And the amount of memory allocated for each data house also increases according to the performance level. So we also have an increased amount of memory allocated for our environment. In the case of the W2000, we have 1200 gigabytes of memory allocated to our SQL dedicated pool, which is a quite good amount of memory. Yes, it's a quite good amount of memory. So what exactly this table means? We're talking about 60 distributions. For example, when I talk about 60 distributions, I'm saying that when you look to your Synapse Explorer and you see one single table inside your SQL dedicated pool, that SQL table is hidden a secret from you. That SQL table is hidden a secret. The secret is that it's not a single table. It's in fact 60 tables. That table is 60 tables, not a single table. And I prove that just in a while. So distribution numbers, it's always 60 distributions, always. And we have 2 databases for each distribution. Yes, because when I talk about distribution, I'm not only talking about breaking down tables. Would the tables be on a single database? Nope. Nope. Synapse Analytics create different databases for the distributions. And it's not only 60 databases, but it's 120 databases. For each distribution, we have 2 databases. Why 2 databases? Because one database will be for the data itself that will be included on that distribution. The other database will be for cache. So that's why each distribution has to database. And we don't see this on the UI of the Azure Synapse Explorer. We will not see this on the UI. If you want to see this, we need to dig deep to see details about the internals, about how our SQL dedicated pool is working. And our data is equally divided among the compute nodes. All the distributions will be equally divided among the compute nodes. So it depends on the performance level that we chose that defines the number of compute nodes that we have. The number of distributions is fixed, but the 60 distributions will be equally divided among the compute nodes. So how to analyze this physical structure? Because we open Azure Synapse Explorer and we see one database in our tables, regular tables. This may mislead us to think they are a single SQL database when it's not true. How do we analyze the physical structure? We use DMVs. DMVs, sorry, I wrote wrong there, DMVs. Regular DMVs are still there. So I can still, sorry by the bell sign, someone is at the door, my wife will take care of it. I'm not sure if you are hearing the bell. But continuing, I was talking about regular DMVs, they are still there. Regular SQL DMVs, most of them are still there. But we have special DMVs that are intended to manage the MPP architecture and to expose to us the physical MPP architecture and how the execution happens inside the physical MPP architecture. These DMVs usually start with the PDW letters, or some of them start with DM PDW. Some are sys PDW, some are DM PDW. And the oldest one among of them, and maybe you may be a bit shy to reveal your age, but the oldest one among you may remind that before all this, before Azure, on the time that everything was on premise, we had a SQL Server. We could say edition, but it was not really an edition, it was an appliance. And this appliance was called Parallel Data Warehouse. And the idea of the SQL Server Parallel Data Warehouse was exactly to be an MPP architecture, massive parallel processing architecture that we could implement in an on-premise environment. This is about some decades ago, before Azure. Before Azure environment, we had this. We could implement this appliance. I didn't have the luck to work with a PDW at that time, but the DMVs are similar to the DMVs that were used on the PDW so many years ago. Then on Slack, I would like to hear your confession. Who really reminds the PDW and who really even touched the PDW to manage a PDW? I will be on Slack and I would like to hear your confessions about that. Don't try to hide your age. So System DMVs that we need to take a look. We have the CSPW nodes table. We have the CSPW nodes PDW physical database. We have the PDW table mappings. What's table mappings? Because we have our regular tables and we have the physical tables inside the PDW environment. So we need to make a mapping between our regular tables and the physical PDW tables that have a completely different name. So we create a table called test, and this table is broken down in 60 distributions, and each distribution is a different table name, has a different table name, and we need a mapping between these internal table names and our logical table, let's say like that, test. And the PDW table mapping does that. And the PDW nodes that can show us information about the nodes available on our environment. And these nodes change according to the performance level that we choose for our dedicated pool. So let's start seeing a demonstration. So I have here a dedicated SQL pool on my Synapse Explorer. I made an interesting comment before. I mentioned how the Synapse dedicated pool is more expensive than a regular SQL database. That's an absolutely fact. Synapse dedicated pool is more expensive than a regular SQL database because it's intended for massive parallel processing. Example, how expensive is a Synapse dedicated pool? Here, I mentioned that I'm using the DW2000 performance level. That's almost the lowest performance level. I included 4 nodes on this performance level. And how much this cost for me? This cost for me $24 for hour. Each hour of use of this dedicated pool cost me $24. If I leave this running up and running an entire day, is $240. Is more than a regular amount on a free Azure account, for example. So for me that I'm a speaker, this is a critical factor that I should never forget it enabled. If I forget this enable, I lose all my Azure credits. But the point is, if you have an amount of data that needs MPP processing, this may be quite affordable and cheap for you. The problem is if you by mistake choose a Synapse dedicated pool when an Azure SQL database could cover your requirements. So you need to take care about that. Take care about the choice. You go to the Synapse dedicated pool when you need a massive parallel processing. It's not only a matter, oh, let's put a data warehouse there. What's the size of the data house? It's not only a matter, let's create our database there. No, this is not a SQL database. This is an MVP environment. So take care about that, or you'll be expending more money than you may initially planned. So here on the scripts, I have some scripts that I prepared for this demonstration. So I have here node distribution script. First, I'll check the nodes table available. Let's execute this query to check the nodes table available. And you may be noticing things out of the common use. Check these table names here that we have here. They are completely different. You can't even correctly identify what are these tables because they use an internal name. Yes, this is the physical structure of our Synapse dedicated pool. My dedicated pool database have these tables that you can see here. And I'm using some different namespaces. You'll notice in a while the difference of these namespaces. So I have some tables under the DBO namespace and some tables under the HSH namespace. Okay. So I can use table mappings to identify the mappings between the logical tables and the physical tables. For example, here I'm saying my table strip is mapped to many physical tables. What I said, one logical table that I see on the Synapse dedicated pool is broken down in many pieces for processing. Yes, one single logical table is broken down in many pieces for the processing. Then let's making some group bys and take some conclusions about the totals related to these tables. So here I'm seeing the tables and the number of physical tables that each logical table has. And see, this number is fixed. This number is fixed on 60. Exactly what I told. We have 60 distributions, 60 physical distributions for each logical table on our Synapse dedicated pool environment. And that's great. Mind that to be sure that I'm bringing the correct result, I had to take care of the schema. I have tables with the same name in different schema. If I don't take care of the schema, I would bring some strange numbers here because it would mix tables from different schema and totalize them. So I would need to take care about the schema to really bring a correct result. And now I can make a select to see details about the physical database. Physical database. Because I mentioned that we don't have only these strange physical tables. We have physical database. We have physical database. And these tables, these strange physical tables that I just displayed, they are contented, they are inside this physical database. So I think people think that when they create a dedicated pool, they have a single database. They don't. They have 60 databases. Sorry, not 60. They have 120 databases because each one of the 60 distributions have two databases. One database for the data and one database for the cache. So when we create a SQL dedicated pool, we are in fact creating 120 databases. Let's take a look on the nodes. I can make a query over the sysdm pdw nodes to check how the nodes are. And we can see some interesting details. I showed before that my performance level is the W2000, and the W2000 performance level is intended to have 4 compute nodes, and it has exactly 4 compute nodes, but it has an additional node that is the control node. The control node is the node who receives the query, distributes the query among the compute nodes, and then receives back the results of the query from the compute nodes, join everything together, and give us the result. So we are talking about 5 nodes, 4 compute nodes, and 1 control node. Let's take a look about the distribution of the data among these nodes. Now, this query is showing the relation of distribution and nodes. And see that I have 15 distributions on each compute node. But if you are really pay attention to this, you'll notice that this query is returning only 4 nodes. And on the previous query, we saw that we have 5 nodes. Which node is not here? The control node. The control node doesn't hold any distribution. The control node is intended to receive our queries and break down our queries among the distributions and the compute nodes. So our distributions that have always a fixed number, 60, they are broken down among the compute nodes. And since my performance level created 4 compute nodes, I have 15 distributions for each compute node. That's great. And then let's continue now talking about table and physical locations of the tables. Let's take a look of this query. I'm using the same system DMVs that I mentioned on the slides. These are the same system DMVs that I mentioned on the slides. And here I'm seeing the tables, the logical tables, and how these logical tables are mapping to physical tables, including the presence of them in the node IDs and in the distributions. How they are located in the node IDs and distributions. Then I can make some group by and counts to see how these tables are broken down between distributions and nodes. So let me execute this query. Where is it? It's saying I wrote something wrong on this query. Oh, it's just a matter of selecting the entire query. Something was not very well selected. So now I can see the logical queries, the logical tables, and I'm seeing that each logical table is broken down always in 60 distributions. And these 60 distributions are broken down in 4 compute nodes. So the number of distribution is fixed, is always 60. And the number of compute nodes depends on the performance level that I configured for our Synapse environment. That's it. So with this example, we are seeing what lays behind what appears to be a single database. It's so nice that Synapse Dedicated Pool appears to be a single database, but this guy is hidden from us all this internal breakdown that is made with our data to ensure a fast processing, breaking down our data in many compute nodes. So breaking down the data in many different compute nodes. Okay, let's go back to our PowerPoint. So we talked about our table distributions among these nodes. Let's talk more about the tables inside the Synapse Dedicated Pool. They are different than the regular tables. The tables that you created in a dedicated pool, they are very different than the tables that you create in a regular SQL database. They are very different. First, they will be using column store cluster index by default. This is the full of Synapse Analytics. You create a table, your table will have a column store cluster index by default. By default, you have this index. There is an option to create tables using heaps or using row store cluster index. These are options that you could choose on some special situations. Primary key and unique key needs to be non-clustered. We are so used on a regular SQL database when we created primary key clustered, especially to avoid index fragmentation and so on. These are problems of a regular SQL database, not here. Here, primary key and unique constraints needs to be non-clustered because the cluster is already created inside the table and they need to be not enforced. These keys will not be enforced. And we have a very special settings that we need to specify for every table. This special settings is called the distribution settings. We need to define how our table will be distributed among the 60 distribution space that we have. So let's talk more about table structure. Let's see some examples about creating table. If I make this create table on the left without specifying what kind of index I want, the default is a clustered column store index. So this table test1 is created with a clustered column store index by default. This is the same than the other statement that you are seeing on the right that adds a clustered column store index to the table. Both statements have the absolutely same result because the default in Synapse Analytics in a Synapse dedicated pool is to create the tables using a clustered column store index. Then we creating a table, we can also create a table specifying that we don't want a column store index. We can create a table just using heap. That's a possibility in some cases. And last but not least, we can still use whole store index, in this case, a regular cluster index on the table instead of the column store index. It's possible. There are very special situations for that. I would not went for those for a heap or for a whole row level index, row level cluster index. I will not go for that by default, only in special situations. And primary key can be created inside a table on the Synapse dedicated pool, but it needs to be not enforced. It needs to be not enforced. So let's talk about the data distribution. We saw that we have 60 distributions. We saw that each table will be broken down on the 60 distributions that we have. But how this broken down will be done? There are different distribution methods, and we can choose these distribution methods when the table is being created. When we create the table, we can choose these distribution methods. Round robin is one of distribution methods. The round robin will just distribute our records along the distributions slots that we have, and it will make an equally distribution. Each new record will go to the next available slot and make a rotation along the slots. So we end up with very equally distributed amount of data along the slots. But there is no data criteria for this distribution. And the fact that there is no data criteria for this distribution affects our query in some ways. Let's talk about that. Another way to make the distribution is called hash distribution. On a hash distribution, we should choose a key. We choose a key for the distribution to be made by that key. So Synapse Analytics will be creating a hash of that key and will be aggregating the hash of that key in different distribution slots, but will be including on each distribution all the similar and closest hash of the key. So our data will be in some ways aggregated by that hash key. So each distribution will have the closest values of that key as possible. If we choose a bad key choice to lead the distribution, this will lead to a bad distribution, and this may lead to a bad query, and that's not good. I'm sorry, is my screen shared?
No, I think we've lost your presentation, Dennis.
Let me share again the screen. So I'm not sure exactly what point was the presentation lost. I was talking about the round robin that is intended to equally distribute the records along the 60 distributions, and the hash distribution that is based on a hash, on a key, and will make
Dennis, we had audio. Audio was fine. It was just the slides that we lost, so you can just pick up from where you got to.
Are the slides back?
Yeah, we should probably wrap up now because we've got another session kicking off. So we need to get into the lightning talk. So you had it's 9:45. So we've got another session starting in a couple of minutes. So do you want to do a very, very quick 1 minute wrap up?
Okay. I thought the next was 11. So let me try to wrap up this 1 minute to wrap up. It will be too close. Let me try to make some demos in relation to this, in relation to the data distribution. So the first query is showing the tables and the index that the tables are using. Some tables are using clustered column store and others are using heaps. In this case, only the external tables are using heaps. Then this query will show the distribution on every table. The distribution is displayed on every table. Some tables are using round robin and some tables are using hash distribution. So I have round robin and hash distribution on these tables. And let's go directly to an example. I have here a query. This query is made this query here is on the top is made joining trip table with date table, and both are using round robin distribution. Let me execute this query using round robin distribution. And this query using round robin distribution is taking 1 minute and 818 seconds. This one is using round robin distribution. But the point of this table using round robin distribution is that the data has no criteria to be distributed among the distribution. So we have a lot of data movement among the distributions. But if I get the same query using a hash distribution, like here, you see the time taken was 1/606. The amount of data is not enough to create a huge difference, but you can see that the tables using a round robin distribution took about 200 milliseconds more to process than the tables using a hash distribution, because the tables using a hash distribution were better distributed on the distribution slots, and there was less data movement across the distribution slots. I have one PowerPoint that illustrates that. Just
Dennis,
to-
can we make that the very last thing, because we're just running a little over now.
Yeah, this slide.
I'm gonna wrap you up in 30 seconds. So can you just finish up?
This slide is showing what I'm talking about. This slide is showing that in some cases, in some queries, if I'm using, for example, round robin, I will create a lot of data movement among the distributions. But if I'm using another distribution method, like for example, a distribution method by hash method, so I would avoid the data movement across the different distributions. So, due to the time, I thought it was until 11, but it's not. Due to the time, I had to cut some demonstration that I was about to demonstrate the data movement and so on. So, that's the idea. And
Right.
I think this that I show until now illustrated very well how a SQL dedicated pool is way more than a regular SQL database. People think that this is a regular SQL database, and it's not. It requires more planning. It requires way more planning than most people think.
Okay, great. Thank you for
So
that.
I
We just
leave
need
this
to-
my contact.
Okay. We just need to switch over to Rob Farley's lightning talk. So I'm just going to schedule that up.
Okay, thank you very much.